Hello everyone, welcome again to another lesson in General Mathematics. In this lesson, you will learn how to find the intercepts and zeros of rational functions. From your previous lessons, you have learned about the Cartesian plane. The Cartesian plane consists of two perpendicular lines, namely the horizontal axis, or the horizontal line is what we call the x-axis. The vertical line is what we call the y-axis, and their point of intersection is what we call the origin. So as you learn how to find the intercepts or zeros of the rational function, we will be dealing with the y and the x-axis. So let us begin with example number 1. We have here a function f of x which is equal to x minus 4 divided by x plus 4. If you will try to graph this function, it will look like this. And if you have noticed, the graph touches the y-axis and the point of intersection is located here. This point of intersection where the graph touches the y-axis is what we call the y-intercept. And if the graph touches the horizontal line or the x-axis and it is located here, which is the point of intersection between the graph and the x-axis, we call this as the x-intercept. Therefore, an intercept of a rational function is a point where the graph of the rational function intersects or touches the x or the y-axis. So here from this example, the x-intercept is x is equal to 4, or the x-intercept is 4, which is x is equal to 4, and the y-intercept is equal to negative 1. So what is an x-intercept? An x-intercept is the value of x which makes the function equal to 0. It is also a point on the graph that touches the x-axis. And it is also referred to as the zero or zeros of the rational function. So how do we find the x-intercept or the zero of the rational function? So we have here in example number 1 from our previous example, the f of x which is equal to x minus 4 divided by x plus 4. We're going to find the x-intercept or the zero of the rational function. So to solve or to find the intercept, the x-intercept, first we have to follow the solution or the steps. We have the first step, we have to equate the numerator to 0. So from our example, we have to identify what is our numerator. And of course, the numerator is x minus 4. So we will equate the numerator to 0 since we're looking for the zero of the rational function. We will identify what is the value of x that will make the numerator equal to 0. Second step, we're going to solve for the value of x. So to solve that, we have to simply copy the first step and solve for x by simply transferring negative 4 to the right of the equal sign. That is the shortcut method, or just eliminate negative 4. To eliminate negative 4, we have to add positive 4 on the left side and also on the right side of the equal sign. Therefore, if we're going to follow the shortcut method by simply transferring negative 4 to the right of the equal sign, negative 4 will become positive 4. Therefore, the value of x that will make the numerator equal to 0 is equal to 4. And this is our x-intercept. We will try to graph the given function. The graph looks like this. And the x-intercept is found here since our x-intercept is equal to positive 4. So take note that the graph of the given function touches the x-axis at point 4, which is x is equal to positive 4. So take note, this is where the graph touches the x-axis. And we have found the x-intercept. We have another example. Again, find the x-intercept or 0 of the rational function f of x, which is equal to 2x minus 3 divided by x plus 3. So simply follow the solutions to how in finding the x-intercept. First, we are going to equate the numerator to 0, then solve for x. So identify what is your numerator in this given example. So our numerator is 2x minus 3. We have to equate the numerator to 0 in order for us to find the x-intercept or the 0 of this rational function. And then, if after equating the numerator to 0, we have to solve for x. So to do that, we have first to eliminate negative 3. So the shortcut method is by simply transferring negative 3 to the right side of the equal sign. Therefore, after transferring, since we have negative 3 on the left side, it will be changed into positive 3 on the right side. Therefore, we have a new equation which is 2x, which is equal to positive 3. So to solve for x, we have to eliminate positive 2. So to do that, we have to divide 2x by 2 in order for us to eliminate 2. So if you have to divide 2 on the left side, you also have to divide 2 on the right side of the equal sign. Since we have eliminated 2 divided by 2 is 1, no need to write 1, just bring down x, and it is equal to 3 halves, or simply divide 3 by 2, we have positive 1 and 5/10 or 1.5. Therefore, our x-intercept is 3 halves or 1 and 5/10. If you will try to graph the given function, 2x minus 3 divided by x plus 3, it will look like this. Since our x-intercept is 1.5 or 3 halves, 3 halves is located here on the x-axis. And take note that this is the point of intersection of when the graph touches the x-axis. So this is now our x-intercept for the given example number 2. Let's proceed to example number 3. This time, we're looking for the x-intercept of f of x, which is equal to 2 divided by x minus 4. So simply follow these steps. First, we have to equate our numerator to 0, then solve for x. Since our numerator is a number or is a constant, which is positive 2, take note that if the numerator is a constant, remember that a constant is a number which does not have any variable. From our given example, 2 doesn't come with any variable. It doesn't have x, y, or z. So it is only a number. Remember or take note that if the numerator is a constant, the function doesn't have an x-intercept. Therefore, for this given function, it doesn't have an x-intercept. If you will try to graph the given function, you will notice that the graph doesn't have an x-intercept, or simply it does not intersect the x-axis. Therefore, it doesn't have an x-intercept. Let's try another one. We have here another function, f of x, which is equal to x squared plus 6x plus 8 divided by x plus 3. So again, follow the steps. First, we have to equate the numerator to 0. Since this is our numerator, we have to equate that to 0. Take note that the numerator is expressed as is an example of a quadratic polynomial. So first, we have to simplify this polynomial by factoring. If you have recalled the lesson how to factor out a quadratic polynomial, it is expressed in this form. So the factors of this polynomial are x plus 2 times the x plus 4. Since we have here a quadratic polynomial with the exponent of 2, meaning we have 2 values of x. So we have 2 x-intercepts. So how do we find the x-intercept of the quadratic polynomial? So first, we have to equate each factor by 0. So we have here x plus 2, which is equal to 0, and x plus 4, which is equal to 0. Then solve for x. So from our first factor, so we have to simply transfer positive 2 on the left side, or on the right side of the equation, it will become negative 2. Here, we can also transfer positive 4 to the right side, it will become negative 4. Therefore, the values of x-intercepts are negative 2 and negative 4. So these are the x-intercepts, or the zeros of the function, meaning negative 2 and negative 4, if it will be substituted to this x, to the x's of the function, it will become 0. If we will try to graph the given function, the x-intercepts are located here. So since the x-intercepts are negative 2 and negative 4. So these are the points of intersection where the graph of this function intersects the x-axis. Let's have another example. We have the rational function f of x, which is equal to x minus 1 divided by x cubed minus 4x. So simply identify the numerator and equate it to 0 and solve for x. Since our numerator is x minus 1, it is equal to 0. So to solve for x, we will simply eliminate negative 1. The shortcut method is simply transferring negative 1 to the right side of the equal sign or the equation. So since it is negative on the left side, it will become positive on the right side. Therefore, the value of x is positive 1. Therefore, our x-intercept or 0 of the rational function is positive 1. If you will try to graph the given function, the x-intercept is located here, which is x is equal to positive 1, since the x-intercept is equal to positive 1. So this is the point of intersection where the graph touches or intersects the x-axis. This time we will learn how to find the y-intercept, but let us first define what is y-intercept. So the y-intercept is the value of f of x when x is equal to 0. It is also a point on the graph that touches the y-axis. Let us start with the first example. Find the y-intercept of f of x, which is equal to x minus 4 divided by x plus 4. So simply substitute. We have the first step, substitute 0 to all x. So from here, from our given example, we have here the x from the numerator and the denominator. So simply substitute x, substitute 0 to all x's. So we have here the new function, the function of 0, which is equal to 0 minus 4 divided by 0 plus 4. So you will not see any x here because we have substituted 0 to x. Then we have to evaluate the function f of x. So simply simplify the given function. So 0 minus 4 is equal to negative 4 and 0 plus 4 is equal to positive 4. So simplify. Negative 4 divided by 4 is equal to negative 1. Therefore, since if x is equal to 0, the f of x is equal to negative 1. Therefore, this is our y-intercept. The value of y-intercept is located at y, which is equal to negative 1. So from the graph of the given function, we can identify the y-intercept, which is located on the y-axis, and it is found here since our y-intercept is equal to negative 1. Notice that the y-intercept is the point of intersection between the graph and the y-axis. Next, we have another example. So find the y-intercept of this given function, which is 2x minus 3 divided by x plus 3. So to find the y-intercept, simply substitute 0 to all x and evaluate the function. So here we have the x from the numerator, and we also have an x here in the denominator. So just simply substitute 0 to all x. So we have here a new equation. The function of 0 is equal to 2 times 0 minus 3 divided by 0 plus 3. So if you have noticed, you can't see any x anymore because it is substituted by 0. Next, we have to simplify. 2 times 0 is 0, and 0 minus 3 is equal to negative 3. 0 plus 3 is equal to positive 3. Simplify. Negative 3 divided by positive 3 is equal to negative 1. Therefore, when x is equal to 0, the value of the function is equal to negative 1. Therefore, the y-intercept is negative 1. If you graph the given function, the y-intercept is located on the y-axis, and it is found here since the y-intercept is equal to negative 1. So take note that the y-intercept is the point of intersection between the graph and the y-axis. Let's proceed to another example. Find the y-intercept of f of x, which is equal to 2 divided by x minus 4. So to do that, simply substitute again 0 to all x and evaluate the function. So from the given function, we only have x found in the denominator. So we will substitute x to 0. So we have here another function, f of 0, which is equal to 2 divided by 0 minus 4. So simplify. Copy 2 divided by 0 minus 4 is equal to negative 4. Simplify. 2 divided by negative 4 is equal to negative 1/2, or negative 5/10 or negative 0.5, since positive divided by negative is negative. So when x is equal to 0, the value of the function is equal to negative 1/2 or negative 0 and 5/10. And this is our y-intercept. So if we will try to graph the given function, the y-intercept is located on the x-axis below the origin, since it is negative. Since our y is negative 0.5, it is found here. And it is the intersection between the y-axis and the graph of this given function. Let's have another example. So this time, we will try to find the y-intercept of this given function. So x squared plus 6x plus 8 divided by x plus 3. So we will simply substitute 0 to all x. From the given function, we have the following x's. So we have here from the numerator, we have here the following x's from the numerator and the denominator. So simply substitute 0 to all x's. So we have a new function, the function of 0, which is equal to 0 squared plus 6 times 0 plus 8 divided by 0 plus 3. Simplify. So we have 0 squared, so 0 times 0 is 0. 6 times 0 is 0, so 0 plus 0 is equal to 0, plus 8 is equal to positive 8. And 0 plus 3 is equal to positive 3. So simplify. 8 divided by 3 is approximately equal to 2 and 67/100ths, because we have rounded off to 2 decimal places. So that is why the function of 0 is approximately equal to 2.67. And this is our y-intercept. From the graph of the given function, the y-intercept is located here. Since the y-intercept is approximately equal to 2.67. So take note that it is the intersection between the graph and the y-axis. And we have here another example. We will identify the y-intercept of the function of x, which is equal to x minus 1 divided by x cubed minus 4x. So simply again substitute 0 to all x and evaluate the function. From the given function, we have the following x's. So simply substitute 0 to all x. We have a new equation, the f of x, or the function of 0, is equal to 0. Again, all x becomes 0. So we have 0 minus 1 divided by 0 cubed minus 4 times 0. So simplify, 0 minus 1 is equal to negative 1. 0 cubed is 0. 4 times 0 is 0. Therefore, 0 minus 0 is 0. Simplify again, negative 1 divided by 0. Remember that if numerator is divided by, if the denominator is 0, it is automatically undefined. So if there is no solution, or if the function, when x is 0 and the result is undefined, therefore the function does not have y-intercept, because when x is equal to 0, it is undefined. This is the graph of our given function. Take note that the graph does not intersect the y-axis. Therefore, this graph does not have a y-intercept.